everyone. Everyone, can we please take our seats so that we can get started with our spotlight session? Dr. Greenleaf, that includes you. So I'm going to introduce you. So we expect more people to be coming in from the other floors to listen, to join us at the spotlight session. But it gives me great pleasure to welcome and introduce Leroy Hood, MD, PhD. I have a very long, deep bio written by Robert Kilpatrick. Thank you, Robert. Dr. Hood is Senior Vice President and Chief Science Officer at, can people stop talking in the corner back there, please? It's your mother. Senior Science Officer at Providence St. Joseph Health, Chief Strategy Officer at, what did you write here?
Institute for Systems Biology.
Institute for, oh, and Professor, I can't read his handwriting. Yeah. Institute for Systems Biology, and he is currently the CEO of the Phenome Health, managing a new initiative beyond the Human Genome Project. Robert, this was truly a challenge, understanding your handwriting, but we did it. We accomplished it. Dr. Hood.
Okay, thank you. Well, it's a pleasure to be here and tell you about a project that is in part about science, and that's mostly what I'll discuss, but it's really about people and how to change fundamentally their health, both for body and brain. So what exactly is the vision that underlies this? Let's see, there we go. It is the idea that we can assess the health trajectory of each individual throughout their life and use the data that makes those assessments to optimize health. And we'll tell you exactly how we can do that. And if you think about a health trajectory, there are three stages that it can fall into: wellness, which most people start initially with. You transition one or many times to disease. The disease progresses, you go back to wellness, or you end up dying. So wellness, transitions, and disease are the three stages. And what I'm going to argue is we can do something with this new program where we're able to identify transitions years before the disease clinically manifests and reverse them. So we can see in the future, you will continue in wellness except for the disease transitions that are reversed. And that means I think most people will be able to live into their 90s or even 100, mentally alert and physically capable. So this is essentially P4 medicine, and it's predictive, preventive, personalized, and participatory. And the first three Ps are really about science. That's mostly what we'll talk about. The fourth P is participatory, and that's the whole question of how do you get the patients, the physicians, the medical leaders, the regulators to participate in what I think is going to be the largest paradigm change or shift in medicine. So let me tell you about the four Ps, at least as we are at this stage. And just to give you a quick background that sets the framework for how you think about this, I'll talk about my career starting at Caltech when I was interested in human complexity and thinking about the challenges that one needed to surpass to be able to deal with human complexity. And in the course of this, we dealt with 7 of these challenges, which kind of frame this program, which we call Beyond the Human Genome Project at this point in time. So in the first 20 years or so of my career, we developed 6 instruments, including automated DNA sequencing, that basically gave one the ability to generate a lot of data from single individuals. The second, I got invited to the first meeting ever held on the Human Genome Project in 1985 because of the automated sequencer. And there was enormous skepticism. I would say of the 12 of us that went to this meeting to pass judgment, 6 were absolutely opposed to it because it was big science, and big science would destroy small science. And of course, the Genome Project, what it did for us was to give us access to human variability, genetic variability, and the ability to correlate it with wellness and disease phenotypes. And we'll talk about that later. I realized that in developing these instruments, I created an enormously large lab. I had at one time a group of close to 100 individuals, and I decided a much better way to handle the need of a cross-disciplinary environment to develop technology was to create a cross-disciplinary department where each of the experts could be a faculty member and not one big lab. And I suggested that to Caltech, and they turned me down flat, but Bill Gates let me actually move to the University of Washington in 1992 and set up the first such cross-disciplinary department. And it was absolutely spectacularly successful. But what was interesting about that department and a state university was when I tried to push on top of that systems biology and global holistic thinking, the University of Washington was incredibly resistant to that. So I resigned and started a nonprofit, the Institute for Systems Biology, in 2000. And we pioneered the early systems approaches to biology. And then we started thinking about humans, and it was where we first enunciated in the early 2000s the 4 Ps of medicine, and realized that healthcare really had 2 domains, one of which was completely ignored then, wellness and disease. And it was in 2013 and 14 that we did our first precision population studies, generating an enormous amount of data on a small number of individuals. And we proved the power of being able to look at your trajectory and optimize wellness. And I'll say more about that in just a few moments. And the final opportunity came in 2016 when the CEO of Providence St. Joseph's, a very large healthcare system, 51 hospitals on the West Coast, 10 million patients, approached me and said, "We'd like you to be chief medical officer, chief science officer, and we'd like you to bring systems biology, genomics, and scientific wellness to Providence." And so I agreed to do that, and that's when the project I'm going to talk about today was born, which we call Beyond the Human Genome, and it's all about analyzing the trajectory of each and every one of you and giving you the tools to lead a long, healthy life. And the importance is we do it for your brain as well as your body. So let me ask all of you, have you ever gone to a doctor and as a doctor asked you one single question about your brain? I would suggest 90% of you would say no. And we'll show you exactly how we're going to do that. So what we propose to do then, in contrast to the first Human Genome Project, which generated 1 genome sequence over 13 years, is Beyond the Human Genome will generate 1 million sequences and their longitudinal phenomes over 10 years. And of course, we want to convert these data into actionable possibilities that can improve health. And what we're going to do is seek new federal funding and support from the government. And without going into any detail, we've really received a lot of encouragement for this. So I hope we won't go on a continuing resolution, which would mean for this year, the end of the project, but we'll see. So what we're announcing today is a nonprofit company called Phenome Health, which together with partners is going to manage this whole project. And it's the longitudinal phenome that moves us beyond the Human Genome Project. And the genome, of course, is the sequence of your 23 pairs of chromosomes, and each individual is absolutely unique in their genomes, including identical twins. The phenome, of course, is the convergence of your lifestyle, of your genome, and of the environment and what it does to you. And the phenome is a point in time where it's integrated those three factors. And in your lifetime, you have an infinity of phenomes, but we can assess them at different points using blood analytes or gut microbiome or digital health measurements. And we use all of those three. We have three proof of principles for precision population health. So one, we started in 2015, a company called Aerovale for bringing scientific wellness to consumers. We recruited 5,000 individuals, and we were able to create longitudinal data clouds, genome sequence plus phenome analyses over this 4-year period. And these data, when analyzed, and I'll talk briefly about that, led to science-driven and data-driven, a science of wellness and a science of prevention. And those two things, wellness and prevention, are the essence of what Beyond the Genome promises to do. We've done recently a fascinating study, observational study on COVID-19 with now almost 300 patients. And we use genome phenome analysis on them, but we use deep immune phenotyping, where we analyzed at each blood draw 5,000 white cells with complete transcriptome analysis, 250 cell surface proteins, 40 secreted proteins. It defined the type of cell for each one of those 5,000 and its state of differentiation. And this deep immune phenotyping transformed our understanding of the immune response to COVID and defined many new features that had never been seen before. And I won't have time to talk about that, except the deep immune phenotyping is a very powerful tool for virtually any disease, because there's no chronic disease for which the immune system does not play a central role. And finally, we have as a partner POSIT, pioneered by Michael Merzenich, who essentially is a wonderful person for brain health. And what he has are 40 digital assays for your brain health that can be used to optimize wellness and even early detection of common brain diseases. And I'll say more about that in just a moment. So with Aerovale, we did a complete genome sequence. We looked at of the order of 1,200 blood analytes. We did that twice a year. We got the gut microbiome twice a year, and we did a Fitbit and other self-tracking devices to generate data that, when analyzed, led to of the order of 200 different actionable possibilities, with each individual having a different and unique list of a small subset of those actionable possibilities. If they did what was suggested, it optimized wellness or let you avoid disease. And to give you an example of some of the things we did, we were able to take the 6 data types and do statistical correlations across these and show that we had more than 3,500 statistical correlations. And they led to actually interesting, actionable possibilities. For example, there are at least 6 genetic variants in the genome that block the uptake of vitamin D. If you have 2 or more of these and you have low vitamin D, you have to take mega doses of vitamin D even to be barely get up to normal. I'm actually in that category. So putting together genome data with blood analyte data gave you an actionable possibility that's transformational. And frankly, for COVID, having normal vitamin D levels was really critical, as there have been a number of very effective clinical trials, but we had hundreds of those actionable possibilities. We were able to use the fact that we had individuals from 21 to 93. We could divide them into bins, 10-year categories, and then we could analyze the envelopes within which they express blood analytes, and showed as you got older, you increasingly lost the control of expression of your analytes. And we developed an algorithm that allowed from that one to determine a biological age of any individual, the age your body says you are, as opposed to your birthday, your chronologic date. What we were able to demonstrate in Airvale, for men, for every year you stayed in Airvale, you lost a year of biological age. For women, you lost 1.5 years. And that means the lower your biological age, the better you're aging. And now we're using blood metabolites to measure biological age, and they give you deep insights into how you can optimize your biological aging. So that's a healthy aging process. We looked at 54 polygenic scores, and in this population converted them onto genetic risk from low to very high. And we're able to demonstrate for 2 of these genetic risk scores, you have to treat individuals at high risk, for example, for LDL cholesterol, shown here, differently than you treat individuals for low risk. If you have high risk and high LDL cholesterol, statins and chemistry is all that will bring it down. If you have low risk, diet and exercise do it beautifully. So it means you want to know what your genetic risks are so you can be treated appropriately. And if you're high risk, so you can be followed closely to reverse it before it goes to a chronologic disease. And the final point that was really spectacular is we saw 67 wellness to disease transitions over the 4 years of the Airvale population. 35 went to cancer. We studied 10 of them, and we looked at bloods prior to clinical diagnosis. And we showed one for every one of those 10, we got blood analytes that were enormous outliers that indicated the type of transition and the type of cancer. We looked at proteins that you had, and some of these transitions occurred more than 4 years before the clinical diagnosis. So the idea is we want to be able to reverse these things before it ever gets to actual disease. And with academic and pharma partners, we'll be able to do that. So in a sense, there are 2 examples of aging, the science of aging here, that is the quantitative wellness and healthy aging, and 2 examples of prevention, looking at polygenic scores and then looking at the transitions so that we can reverse them. And so let me tell you what we've done with Alzheimer's. And the reason I'm excited about Alzheimer's is I think at the end of a 10-year period, we'll be able to deal with 80% of the Alzheimer's we see out there. So 1, we've used blood biochemistry to stratify Alzheimer's into at least 6 different subtypes that have to be treated differently. 2, you can assess genetic risk for Alzheimer's either by family history, by ApoE4, a dominant gene for Alzheimer's, or by polygenic scores that have recently been published from the British Biobank. And we'll talk more about those in just a moment. Women are at much greater risk than men for Alzheimer's, and we don't understand why that is true. But it's really important in assessing genetic risk. And so with this, we are going to do prediction. We're setting up a clinical trial now with high-risk individuals to look at transitions and get the biomarkers that mark the earliest ones so we can reverse them very early. And we actually are going to be able then to use multimodal therapy, which is both for prevention and reversal of the disease, which uses a combination of lifestyle, of environmental changes, and of blood chemistry changes. And it looks very promising at this point of view at time. And finally, these multimodal therapies seem to be able to reverse very early Alzheimer's. And there have been some very interesting clinical trials recently on that. And we'd like to be able to scale it to the US and then ultimately to apply it to at least some other neurologic diseases. Now, this is a 5-generation study of 40-some genomes in populations that at the first, second, and third generation all have Alzheimer's, and the last 2 don't because they're too young yet to get it. But for ApoE4 status and the polygenic score status, it's the red rims around the circles or squares and inside the circles that give you the risk. And I could talk about this slide for 20 minutes, but the one important point I'll make is go to the very left of the slide and see in the 3rd generation and 4th generation, the parents and the kids from the parents are both at extreme risk for Alzheimer's, yet the granddaughters have very different outcomes. The 2 on the left with the circle reds both have to be warned that they have to change their lifestyles early in their life, and I think they'll be able to avoid it. They're both women, obviously, whereas the 2 on the right have no particular indication for this. And the important point is, beyond the human genome, feels that the fundamental unit of medicine in the future is going to be the family, because it gives you the deepest and most powerful insights into your family's health and your own health, because you can extrapolate both from above and from below at where you are and what you should do. With regard to different races, Alzheimer's is really striking. On the y-axis is genetic risk. On the x-axis are the different combinations of APO alleles. And the most extreme alleles are APO4 homozygotes, which are indicated here. For Caucasians, if you're an ApoE4 person, you have, by the time you're 65, a 65% chance of Alzheimer's, to give you an idea. But what's striking is look at the Japanese. They are 3 times more susceptible to this disease than those, whereas if you look at Hispanics, ApoE4 doesn't make a difference at all. So we have to understand different ethnicities if we're ever going to be able to distribute proper medicine. Brain health with the 40 digital measurements lets you measure 25 cognitive features, including reaction time, depth of field of visual acuity, and memory, and the like. And the really interesting thing, Mike Merzenich has shown beautifully, and he got the Kevley Prize for this, that for the average individual, your cognitive abilities rise to a maximum in the mid-30s. Almost all people fade away after that and go down. What he's demonstrated that's really important for everyone in this room is the brain is flexible, and he did a beautiful clinical trial with 10 people in their 80s, and he showed with a proper digital management in the brain, he could bring those 80-year-olds back to the level they were at when they were 35. So if you have the will, you can change your cognitive abilities enormously. And the other thing that's really important about wellness is most of us, for both body wellness and brain wellness, are at 30% of our real capacity. And if you want to push those things, you can become weller in both of those capacities. So the gut microbiome is going to be absolutely key to health, but we're in the very beginning. We don't understand a lot about what we can do. We've already demonstrated beautifully that we can measure 11 blood analytes and assess your microbiome diversity easily. And that means you could look at old blood samples and go back and estimate across time longitudinal changes in the gut microbiome. But the most interesting experiment we've done was with 9,000 older people, 60s and 70s and 80s. We were able to demonstrate regarding the gut microbiome that although we start in our 20s and 30s with a core biotaxa that is very common for a given racial set, as you age and age in a healthy manner, two things happen. You lose the core gut microbiome and you uniquely differentiate a gut microbiome that's different from every other older person, responding probably to your unique genetic needs in old age. And in contrast, as the unhealthy people age, you can show beautifully they do neither of these things. They retain the core gut microbiome and they don't diversify individually. So we're thinking about ways that we can push the unhealthy to mimic the healthy behavior. And one of the striking things is across this 4-year study, we looked at 80-year-olds, 80-plus-year-olds, and demonstrated beautifully that the unhealthy individuals had 4 times the likelihood of dying over a 4-year period that the healthy individuals did. So it's a real metric for healthy aging. So the science of wellness and prevention, the science of wellness of the body and brain is quantitative wellness, optimizing your healthy aging. It's using the brain cognition to optimize your cognitive abilities, optimizing your gut microbiome, and then integrating these things together because they operate in the body as an integrated system. The science of prevention for body and brain is using the polygenic scores, as we talked about earlier, identifying those early transitions and reversing them before the disease ever manifests, and then using the power of family analyses for prevention. And these are absolutely going to change how we think about wellness and health in the future, and will bring thousands of new actionable possibilities into being. And in fact, there'll be so many that will need to have AI deliver to the physicians in an understandable manner what it is they should give to their patients and how and why. And we're working on techniques for doing that at this point in time. Here are 13 papers that validate all of the different kinds of things that we've said here. And what we need to do now is move from the science to the sociology of convincing patients and doctors and medical leaders that a revolution in medicine is here and they should adopt it. And that's the 4th P, and that's the hardest thing in the world. So how are we going to do this beyond the Human Genome Project? Well, we're actually going to use the measurements, although we're going to expand them enormously. We'll expand blood measurements. We'll bring in new brain measurements. We'll do the microbiome measurements and the self-tracking with the Fitbit. We're collaborating with Google now to modify the Fitbit that may be able to do a lot more things than a current Fitbit does, but not cost anymore. And that's an important point. We're going to use electronic health records to analyze the patients and social determinants, and these will generate thousands of new actionable possibilities. We're going to have 1 million person over 10 years with the genome phenome analysis. And for implementation, we'll do 100,000 in 3 years, 500,000 in another 3, and we'll finish up the rest in the 10-year period. We have 6 partners, and the really critical partner for us well, there are two. I would say Guardian Research Network, which has access to 30 million patients in 100 hospitals scattered across 13 states in the Southwest. So they bridge racially diverse and economically underprivileged population so we can get a diversity ratio that reflects the United States as a whole. And we think this is very important. But what Guardian Research Network has learned how to do is extract electronic health records from any of the hospital databases that exist out there and to extract the structured data and the unstructured data, the doctor's notes and path reports and all those things. So they have 30 million of these sitting in a computer waiting for us to use them. And I'll tell you how we're going to use them in interesting ways. They've also got a consent that reaches out to all 30 million patients that lets us automatically recruit them to a research project like this. So POSIT, I've talked about. Providence St. Joseph, my hospital system, is actually putting up a pilot program involving 5,000 patients this year to return actionable possibilities for the genome. And we're using that to learn how to educate both patients and physicians and so forth. And then we have other people that are actually helping us as well. So we're exploring federal partnerships. We've talked with NIH and all of us. We've talked with the DOE and with the VA, and they're all enthusiastic about a partnership with us in these regards. And then we have an incredible array of 12 counselors that I'll show you in just a moment. So we put together an operations team for Phenome Health, all really qualified to do the kind of things that we're talking about here. And the advisory council of 12 individuals includes people like Jeff Wilke, who was #2 at Amazon until very recently, who was great in scaling, and he's great in AI. And Roger Perlmutter, who was #2 at Merck and #2 at Amgen before that. And he's been fantastic with the pharma side of things. Ralph Snyderman, who some of you may have heard this morning, who is the father of clinical personalized medicine and so forth. Michelle Williams is Dean of Population Health at Harvard. And George Church is actually collaborating with us in an active way on this process. So we've got really a terrific team. What is unique about it? One, these longitudinal phenome analyses for body, brain, and the gut microbiome. The ability to bring these actionable possibilities to patients with AI. We're going to analyze genome, phenome, electronic health records, social determinants, and outcomes. And we have these data in a way at this point no one else has. And we can feed these data into hyperscale AI, and there are only 2 in the world. And this is essentially AI that has orders and orders of magnitude more computational power for statistical comparisons than anything else out there. And we're talking both with Google and Microsoft about these possibilities. We want to feed all of the data into that. We're going to include academic and industrial partners to bring all this knowledge to society. And a really important point is we're going to use the electronic health records to select out patients that fall either in risk or actual, in fact, disease for the 4 most costly chronic diseases. So cardiovascular, cancer, diabetes, and Alzheimer's. So this means that we'll have the data then to do things that I'll show you in just a moment. And finally, we'll also be able to, for essentially every drug, be able to determine biomarkers that will tell you which patients can successfully respond to the drug. Okay, and that's important, as you'll see in just a moment. So what we can do is take, say, a diabetes patient where 10 to 15% of the patients respond to a given drug, we can stratify it with data into the different subtypes. For the big chronic diseases, I suspect these will be 30 or 40 different subtypes. And what we can do then is for each subtype partner to get drugs that will uniquely attack them and give very high rates of success. And of course, this is a whole new paradigm for drug discovery and treatment, and it's going to be a challenge to convince pharma to do that, except for the daring and adventuresome. The other point that I think is really interesting is we can also use the high-risk patients to identify and mark the earliest transitions so we can do the early reversal of disease that I talked about before. $500 billion a year we spend on drugs. These are the top 10 selling drugs today. The pink individual is the responder. Less than 10% of the patients respond. More than 90%, don't. So it means, and if we can pick out all the responders, look at the money that can be saved in principle. And of course, pharma is not going to like this. Verticals, we're going to spin off companies that look at all of these major types of diseases. Once we have stratification, beginning to get drug targets, and we'll be able to look at transitions early on. And what's important is in the very near future, we're going to set up short-term trials on acute myelogenous leukemia. It's the ideal cancer to study for a lot of reasons. Long COVID, because we're convinced the symptoms are primarily autoimmune. And kidney disease secondary to diabetes costs hundreds of billions of years. And we're collaborating with Ralph Schneiderman on this kind of a trial. And then longer term risk for Alzheimer's and anti-aging trials that we'll be looking at. The deliverables will be the data system, the biobank, the computational platforms for education, for automation of every aspect of data generation, strategies for including minorities and economically disadvantaged, new approaches to analysis, this hyperscale AI, and then finally creating a partner venture. So it's going to validate the science of wellness and healthy aging. It's going to validate prevention, as we've talked about earlier. It's going to generate the diversity that we need, stratifications of disease for major chronic ones, thousands of new possibilities. We're going to change medicine from disease-driven to wellness-driven kind of opportunities, innovation, new companies and jobs, and catalyze the value-based medicine, and of course, a world leadership in science and medicine. If you look at the four major challenges to contemporary medicine, quality, cost, expanding age group, and explosion of chronic diseases, we have really powerful ways to approach each of these, which I've talked about earlier in this endeavor. So my last slide is just a list of what we're going to be doing in the next month or two. And a key point is we're out to raise $5 million so we can, from philanthropy and foundations and industry, get Phenome Health started. So we'll be in a position to start these early trials and to promote the government pushing this forward to do what is going to be the biggest transformation in medicine ever. Okay, thank you.
So with that said, I'd like to, number one, thank you, but you don't get away so quickly.
Okay.
Does anybody have a question, one or two maybe, for Dr. Hood? Really, only one. You have to promise. You have a reputation now. What was it? 15 questions in one? Okay.
In terms of Phenome, how can you interact with people who are involved with climate change and environmental
So
issues?
what we can, I mean, that's really a great question. So how do you measure what the environment does to your health? So there are lots of ways that you can assess pollutants in the in the environment, and we plan to include those. But the immediate pollutants are in the body itself from the food and diet. So mercury that comes from Susha tuna is a big pollutant for many, many people. And lead you find in many people. And knowing these things and moving to change and remove these metals is a key thing. So, and we're open to collaborating with people that have digital measurements for environmental pollution that can be added to this. But as the program expands, we will really push the environment, because I think that's really a key area. What's the health of people who live next to a freeway as opposed to people who live out on an island? I'll tell you, it's remarkably different in some ways, and you can measure those ways.
Dr. Hood, we adore you. Thank you so much for coming
Okay.
by.
Okay.
So he'll be here for the next few minutes, right, Robert? You're not stealing him immediately as we get set up for our closing plenary. Thank you so much for
Thank
joining
you.
us.
My pleasure.
If you'd like, we can post your slides in our system if you'd like us to.
That's fine, if you wish.
Okay.
Okay. Yeah.
So Robert, we can post your slides in